2003 AB exam, Saturday, April 24th. Okay, guys, first one. Nice, straightforward. What'd you guys get? Chain rule. Bye. All right, what'd you guys get for the first one? You take the derivative. E. You guys got E? You are all correct. Okay, derivative of the outer function, leave the inside alone, times derivative of the inside. Chain rule. Bam. Second one, you got to take definite integrals, so you got to get the antiderivative first. What do you need if you want to take the antiderivative of e to the u? You, of course, need the u, and then you will get e to the u plus c. All right, so what do we need in this case? We need a -4, -1/4. So first we'll say what the antiderivative is. So we have the -1/4, and the antiderivative of e to the u du is just e to the u plus c, so it's e to the -4x. We don't do the plus c here because it's definite. We draw the line. And it's up to you if you want to leave the -1/4 out and distribute or keep it in there. We're going to plug in the 1 first. -1/4 e to the -4 times 1 minus a negative, so plus 1/4 e to the 0.
Is u just -4x?
Yes. So we have negative e to the -4th over 4, and e to the 0 is just 1, so plus 1/4. Did they leave it like that, or did they make it, they simplify it? Strange that they left negative exponents in the answers. We didn't have to simplify it anymore. So it is choice D. Oh yeah, make sure I write down the answers as we're doing this. What did I do for 1? Oops, 1 should have been choice E. Okay, 3. They tell you that y equals 2 is a horizontal asymptote. So in other words, I'll draw it to the side. This is the line y equals 2. You've got a function that's either, as x goes to infinity, because I said for x is greater than 0, you got a function that's coming in like this, or the function's going in like this somehow, okay? And you don't know exactly, you don't know what it's doing before this. You just know if you go out far enough, the y's are going to approach 2. And then they start asking us questions, which must be true. Do you guys have any ideas on this one? E? Yeah, that's how you find horizontal asymptotes. You take the limit as x goes to either positive or negative infinity. They told us x was greater than 0. So what this is saying is that as the x's go to infinity, we know that the y's are approaching 2. So this is the right answer.
For a vertical,
For,
the denominator is 0.
yeah, if you have the equation. If you look at what D says, it says the limit of the function as x approaches 2 is infinity. That would mean that for D, there would be a vertical asymptote at 2, because what this is saying, as the x's approach 2 from either side, the y's are approaching infinity. So what this graph is doing, so in D, they're talking about a vertical asymptote. This just says f of 2 is undefined. You could just have a hole there, you know? So, for which one? Number 2? Let's see. D. All right, and A, you know, f of 0 is 2. Who would ever get that? You don't know that. This one, though, some people probably would write down as an answer, because a lot of people tell you that, you know, an asymptote is a line that the graph approaches but never crosses. Technically, this can still be an asymptote, and this graph could be doing this over here. Okay, graphs can cross asymptotes, but asymptotes describe as what's going on if the x's get infinitely large. If they're getting infinitely close to that line, it's an asymptote, whether or not it crossed before or not. Okay. Oh, what you doing for, kids? Quotient rule. And did you actually get an answer in this one? What choice did you get for? D would be correct. And for our viewers at home, it's because you do a little low-y high, less high-y low, draw the line, down below, denominator square will go. And if you distribute up there and combine like terms, you will get choice D. Let me switch these. Okay. Checking, it's good. 5. You have to take the definite integral of sine of x. So we got to take the antiderivative first, and then we'll plug in the limits of integration. What's the antiderivative of sine x? Negative cosine. See, a lot of times people screw that up because they think the derivative. Negative cosine of x from 0 to pi over 4. And this is why, in that stuff you must know cold, these are, this is without a calculator, so you have to know what the cosine of pi over 4 is. So we'll plug that in. We have to do minus negative cosine of 0, so it's going to be plus the cosine of 0. Now, does anyone remember what the cosine of 45 degrees or pi over 4 is? Pi over 4 is 45 degrees, so what's its cosine? Those are the ones you have. Radical 2 over 2. So you have negative radical 2 over 2. And what about the cosine of 0? Think of your unit circle. Yep. So it is D. Limit as x approaches infinity. What do we do as x approaches infinity? You compare the degree of the numerator and denominator, and if they are the same, the highest power of x up here and down here are the same, Jordan is correct. The limit will be the ratio of the leading coefficients. Hi, take a test. We're doing the 2003. They worked on the first bunch. We're up to 6. All right. Yeah.
For this one, since the denominator,
Oh, I'm still recording.
Also the same degree, just get the ratio, right?
Yeah, you guys have to remember the 3 cases for the limit as x approaches infinity of a quotient of f of x over g of x. Okay, it equals 0 when the degree of the numerator is less than the degree of denominator. So when the degree, the highest power of f, is less than the highest power of g, the answer will be 0. So you'll have a horizontal asymptote y equals 0. It equals the ratio of the leading coefficients. When the degrees are the same. And
Degree of f.
mm-hmm,
What do you mean by degree of
the highest power of x. So like in other words, the degree of this numerator is 3. The degree of the denominator is also 3 because the highest power of x is 3. So when the degree of the numerator is less and you're taking a limit, and this is only true when x is approaching infinity, you get 0. When they are the same, the degrees, you get the ratio of the leading coefficients, the coefficient of the highest power term up top over the coefficient of the highest power term down there. And then if the degree up here was greater, that means that your graph is not going to have a horizontal asymptote, that it's going to be going to positive or negative infinity. So it's going to be either positive or negative infinity. It's not going to exist. You're not going to have a limit.
Which one was the one that you did make on the division for the?
When do we have to do long division in your class?
We never did in this class. We did in Greek.
Oh, because in here, when we did this in the beginning, we divided through by the highest power of x, and then we took the limit. And then we boiled it down to these three cases. I don't remember if we've done long division in here. No, the time that you'd have to do it, if you were going to integrate like a quotient, and the degree up top was like the same or higher than the degree in the denominator, and you wanted to actually integrate it, you would want to divide first, but I don't think that would come up. Okay. So anyway, we never answered this question. So what's the answer in this case for 6? Yeah, because it's 1/4. 5 was D. And 7, oh, I didn't finish writing the question. Okay, they give you a graph of f prime. So this is a graph of the derivative. And it says, which of the following statements must be true about f? And if you just browse through the answers, it's all about increasing, decreasing, local max, or whatever. So let's just make a little first derivative number line underneath this. And we can see that the first derivative is positive when x is less than 0, and it's negative to get to 2. That, and the first derivative tells us about whether a function is increasing or decreasing. So let's see if we can find a true statement in the bunch. Is f decreasing between -1 and 1? No, f prime is, but they're not going to ask us about what we're looking at. B, is f increasing from -2 to 0? That's a good one. Increasing, yeah, right? Because the derivative is positive? Right, so that means f is increasing. So you really need to like get away from the increasing, decreasing of that. Okay, all you care about is the sign of the first derivative as far as whether the function is increasing or decreasing. So that looks like it's an answer. Yeah. It says, choice D says local min at 0. Nope, it's going from positive to negative. It would have been a local max. Okay, so our answer is B. B, f is increasing from -2 to 0. Yes, because its derivative is positive. 8. Should I take the antiderivative of this and multiply it by the antiderivative of that? No, never do that, ever, right?
It's very complicated. First product rule and then change.
Well, when we go to take antiderivatives, if it's a sum or difference, you break it up. If it's a product or a quotient and you can't just do some algebra to fix that, it's going to be U substitution. You do. Because you have to like ignore the du stuff. And what am I really going to be integrating? Yeah, you'll be integrating the cosine of u. As long as you have du, what is the antiderivative of the cosine of u? Careful. It's the sine of u. All right? And we can, so if u is your x cubed, the all-important du, right? You can't integrate anything unless anything that's not x unless you have du. Okay. Yeah, it's 3x squared. So you got to put in a 3 and out a third. And so what we have now is the antiderivative of cosine of u du. And so what do we get for our answer? Right. You get 1/3 sine of u, which is sine of x cubed plus c. And if you don't believe it, you take the derivative of your answer, and you should get x squared cosine of x cubed. Right? You could always, if you have to get an antiderivative, you could always check taking the derivatives of your answer if you want to cheat. Okay. Questions? Oh, thank you. Choice B. Don't mess with me, kids. 9, we got to know how to take the derivative of a natural log. After we do this, we got to plug in 0. So what is the formula that I have to know to be able to do this? If you want to take the derivative of the natural log of u, what does it equal? Dad, say it again. U prime over u. Thank you. Okay. I'll do the denominator. You guys do the numerator. Because I can copy. What a joke. Did you call this exam a joke? All right, just as I heard. Wow. That was Nick who said that. I hope it's working this time. Yep. So what's the numerator? What's the derivative of x plus 4 plus e to the negative 3x? 1. It's going to be minus, yes, right? Because the derivative of the x is 1, derivative of 4 is 0. And the derivative of e to the u is e to the u times u prime, which is negative 3. All right, now we're just going to plug in 0, right? You want? Yes, it is. Yeah, yeah, okay, I thought so. I would skip it because it had e's in it. Usually somebody says that at this point of the question. I'm just waiting. Somebody says something like that. I would just. You did? Yeah. All right, so yeah, e to the 0 is just 1. So did you guys finally get an answer? Negative 2/5, which is choice A. You got to admit, this is borderline fun. This is, you know, yeah. That would be nice. I would love to try. Who's proctoring? I would do that. I like taking these things. Okay, so what are you looking at? You're looking at a, oh, they're saying you got the function's negative. So if the function's always negative, what does that mean about the graph? Where does it have to be? Under the x-axis. So just get rid of e right away, okay? Because the function's not negative there.
It should not be increasing.
The first derivative is negative, which means the function is decreasing. Can't be a because that's increasing then decreasing. Oh yeah, that's just increasing. It's crazy. And then the second derivative is negative, concave down. Obviously has to be b because this is not always concave down. Enjoyable. Ooh, I ran out of writing them. Well, yeah. But remember, they're all work the same. So you don't spend a huge amount of time saying, I'm not going to go into 11 until I do 10, okay? Because it's not going to be good for you, right? You get as many as you can get done. Yep. You know. So what are we doing? We're on 11. You have to write it up. I didn't get to this far. They gave you what to make you. Are you kidding me? That is so nice. I didn't get them anything. I feel horrible. Oh, there's a teaching moment in this question I have to make sure I focus on. Yes, because this is as x goes from 0 to 2. So when x is 0, what does that make you? Yeah.
So you asked 1.
Yeah. 1 to 5. All right, that's that part.
A, B,
Did you guys take care of putting the DU business?
What?
You need to have DU in there. Did you do that yet?
I just put the half in front. You need the 1. I do.
Yeah, we'll write that out. So when x equals 0, u equals 2 times 0 plus 1, or 1. X equals 2. That would be nice. Nice. Evil wish. Okay, so because, normally we don't care what the limits are because we switch it back to x's and we use the limits of integration that they had because it says x goes from 0 to 2. Okay, but if you just switch everything over to u, okay, and you want to just take the antiderivative and not switch it back, you got to convert the limits of integration also. So this is our square root of u. 2dx is our du. And it'll be 1 to 5. Choice C. I agree. It's choice C. Yes. Read it carefully and translate it for me. Now you don't get too crazy. Read what it, like translate the words. The rate of change, hopefully they know what that is, of the volume.
The rate of change is
I hate. Don't hate. I don't like all the hating. Of water in a tank with respect to time. That just means the whatever. T is directly proportional. I hate having to write all this out. Proportional to the square root of the volume. I think you actually had this question on a test. The square root of, actually it was close to this one, wasn't it?
What did you write?
Kids at home, if this works. I want this for the kids at home. Yep, gotta think about them. Okay. Yeah, they're not getting this. The rate of change of the volume in a tank with respect to time t. dv dt. How about the is? Equals, oh, this is color coded. Directly proportional to k times. If it was inversely proportional to, which they don't do, it would be k divided. You remember that by. Okay, directly proportional to, I got to go back to a different color, or I'll have to do black. The square root of the volume.
What does that k represent?
A constant times.
All right.
So the square root of the volume translates into the square root of the volume.
Just changing from the letters to...
Yep. Words to symbols. Translation. So yep, careful.
Oh, yeah, choice
E.
I think... Oh, no.
13.
I think
It's a picture. Got to draw the picture. We have a graph of a function. And at A, we got a little cuspy corner thing. At B, we have a little movable discontinuity there. I don't know what I was saying there. C, we've got a min. D, we've got this little jump. And then at E, we just have a root. And this is a graph of f. And we got to find out where the function is continuous but not differentiable. So we want it to be continuous, but not differentiable. Okay, First, tell me at which of these points is it continuous? Okay, so it's continuous at A, C, right? Because it's not continuous there, and E. But it's not of these. It has. It's differentiable. So not so it's differentiable here and here. So the answer is A. You got that one? Okay, continuous but not differentiable. Okay, 14. Now you guys didn't try up to 14, right? Okay. Okay, so question 14. It sounds like people did the product rule first. Times derivative of the second. Remember the times 2, impressive. Plus the second times derivative of the first. And then gave up because the answer wasn't there. Isn't that correct? You didn't? All right. So what was pulled out? Yeah, they pulled out 2x. They have x cosine of 2x plus sine of 2x, which is there, just the order is switched. Choice E. Nice. I figure you got like 2 minutes of questions, so you can get a question done really quickly. Nice. They gave you f prime here, and they're asking where f is decreasing. They already figured out what f prime is. What do you have to do? See where it's negative, but so first you have to find out where it's undefined or 0. To see, because your critical points, when f prime of x is undefined, we actually have a place here where it's undefined, right? Yeah. At 0. So that's one place it could change sign. To see when it equals 0, you're going to have to combine them into one term. So in other words, if I want to know where x squared minus 2 over x equals 0, I could bring the 2 over x over and cross multiply. Okay? Or I could get a common denominator of x. Either way, I mean, this gives you the whole picture, but if you combine it, or either way, you're going to wind up with x cubed minus 2 equals 0 for the numerator of the derivative to be 0, which would make this 0. Oh, yeah, no, you can't do that. You had to get it to be like a nice little equation here. So this is going to equal 0 when x equals the cube root of 2. So we have 2 critical values, 2 places where the first derivative could change sign. And if we draw a little first derivative number line, break it up at 0 and the cube root of 2, I have to take a number and plug it into the derivative. So let's take a number like 100. That's over here, right? 100, would that make the first derivative positive or negative? Positive, right? Because it'd be 100 squared minus 200. Give me a number between 0 and the cube root of 2. 1. Well, you know it's larger than 1, right? Because the cube root of 1 would be 1. So we'll pick 1. You take a number like 1. 1 minus 2? Negative. And you take some negative number, like negative 1. Okay, so you have positive 1, but then be plus 2, so positive. 0 to the cube root of 2. What choice is that, kids? I don't have my 0 to the cube root of 2. Choice D. Knowing. I love this question. Derivative of 1, I don't even know what the function is. So you draw a picture. Okay, but first we got some graph. I don't know what it looks like, but I know if you draw the tangent line at 1, 7, here's the point 1, 7, that tangent line will go through the point negative 2, negative 2. So actually I want to just, that line is going to pass through, I can't see because my shadow, I missed it. All right, so this is the tangent line, and I don't know what the curve looks like. Maybe it looks like well, that wouldn't really be tangent to it. It had to, the point is the tangent line there would go through this point over here, all right? I don't like my picture over there. Oh, it could be. So, and then they ask you, what is the derivative at 1 of the function?
Yeah, just looking for the slope.
The slope of the tangent line. Can you get me the slope of this line right here? Yes, you can. How do f prime of, you were doing that, Elise? So it's going to be the change of y's over the change of x's. Oops. So you want to be here? What? Huh? Okay. 9 over 3 would be 3.
Nothing but this.
Realizing the derivative is the slope of the tangent.
The derivative of, hold on.
Yes?
What did we just find?
That we had to find the derivative.
So when you find the tangent line, you have to find the derivative, but when you're finding the equation of the tangent line, is you have to do the y minus y0.
Right. The derivative is just the slope of the tangent line. If you want to write the whole equation of the tangent line, you have to use the y minus y1.
Okay.
So
the equation of the normal line, you do the same thing, but use the negative reciprocal of the derivative.
correct. Correct. 17. Want to know when this function's concave down? Translate that into calculus for me. What are they asking me?
Second derivative.
When is the second derivative negative? That's what that means. So we got to get the second derivative, see where it can change signs, break it up, and see where it's negative. Okay, D. You guys can use product rule, right? Okay, I'm just checking first. I'm sure the second. Yes.
It's nice. When we are going to get the second derivative, the second part repeats.
Oh, yeah. For the second derivative, I see what you're saying here. Because we take this term, we already did that.
What?
Now he's saying that, okay, you get the first derivative, which is this. Now you're taking the derivative of this, and through this first term is just what we did.
So it's just repeated. Oh, wow.
Cool, huh? I don't even have to think. I can just think about something else while I'm writing that. I don't have to come back. Plus, so that, all this, was the derivative of just this. We still have to, add to it the derivative of that. Correct? So we can combine some like terms. I hear that. I like it. Really? Okay. Sorry. We took the derivative of the function using the product rule. We did first times derivative of the second plus second times derivative of the first. Derivative of the first is the 2. Okay? Then we had to take the derivative of that because we want to know the second derivative is negative. So we want to take the derivative of this first term. We said, wait a minute, we just did this. I could use product rule all over again. But that's just this whole thing, right? This is what we just took the derivative of. So we did this, and then we had to take the derivative of the 2e to the x, and that's just 2e to the x. So we got our second derivative. We were just about to combine like terms. And you want to know when this thing's positive or negative. You have to first find out when it could change sign. So it's when it's undefined, which is never, or when it's 0. So how are you going to find out when it's 0? Well, to find out when anything equals 0, you're going to have to. Well, e to the x will never be 0. Take a positive base to an x, will never be 0. But what you're saying is you factor it out. That's one of the you got to factor it to find out when it's equal to 0. E to the x will never be 0. Positive base. Yes, I should have. Oh, well, I'll get the same answer. You're right. I could have pulled out 2, and now we're at x plus 2. And so either way, what is my one value of x that makes this 0? Negative 2. So if it's going to change sign, my second derivative, it will happen at 2. At negative 2, I'm sorry. So want to plug in 100 again? That's it over here. So you take a number that's greater than negative 2, like 100. I like 100 better. Is it positive or negative?
Positive.
E to 0 is 1.
Yeah. better. Because you know what these are zero.
I think you can say better. I don't say, yeah, but you know it's positive. And all you care about is the sign. So over here is the second derivative positive or negative? Positive. Because any number you choose over here, you plug into the second derivative, it's positive. Take a number over here, it's going to be negative. And so the question is, I forgot the question, concave down is when it's negative, so it's over here. This is less than -2. So choice A. You know, you can expect the question, where is this function increasing? Where is this function increasing, decreasing, concave up or concave down? So you have to know which derivative and what to look for. All right, so they give you all these points and say there's exactly 2 zeros right here and here. So in other words, you don't have to worry about it doing something crazy and hitting 0 anywhere in between. All right, so you see that the y values on this go from 2 to 3 to 0, -3. All right, and it's continuous, so it's not jumping over anybody. And they want to know, where is g decreasing? So you want, if when g is negative, g prime is negative, I'm sorry. So it's in between the zeros. You don't have to worry that it crossed over somewhere between these, because it told you it didn't.
I was thinking about this at first. I confused it like with the G prime decreasing. So I looked and was saying to myself, it's like from 3 to -3. From 3 to -3 it has increased and it has decreased and so on.
Oh, you're thinking where this is
Yeah, I
decreasing?
was thinking like G prime was decreasing and I was looking for the curves.
So, yeah, so you know where it's 0. They already told you where it is. And you know it can't change sign anywhere else. So what would be my answer then? Or was it A or B? See, you're just looking at these. If you're saying B, you're looking just at these values. But remember, it's still negative for like -1.5 or negative. Okay? So it has to be between the zeros of it. So they did try to trick you, and I think they succeeded.
But you don't know about the numbers peaking, if you know what I mean.
Yeah. But you always, when you find out where is a function decreasing, you find out where is the derivative 0, and then you break up your number line, and it's in between those zeros. Right? No, it's 19. Curve has a slope. This is a party. This is a form of a party. You are very strict in your definition of parties.
That's party after. Is there a final right after people? There's a lot of kids in our class. Okay. Why is it okay? We already started this.
Yeah, it'll be good. You'll be, and then when you have other finals, you'll be like relaxed in here.
I think that Friday we should party.
No.
Did you have any type of homework?
Supposed to finish up those free response from 98. Yeah, and I have the solutions if you want to look. But anyway, you have a curve. It's got a slope of 2x plus 3. What's another way of saying the slope of a curve? Slope of a curve. Nope, it's just the derivative. Slope of a curve is the same as the slope of a tangent. Yeah, so they gave us that the derivative is 2x plus 3. And this curve gave us its derivative, and it has to go through the point 1, 2. And they want to know what the function is. Yep. Question has nothing to do with this. Let's pause. Let's do this. Okay, here's the derivative. Here's the point it goes through. How do you go from the derivative to the function? The antiderivative. I don't know. It's all blurry. So what's the antiderivative of 2x plus 3? Correct. And that's why they had to give us a point, so we could figure out what c is. So you have 2 is equal to 4 plus c. All right. C equals -2. And we go back to the point where we... Y. No, it looks exactly like a -2. Equals x squared plus 3x minus 2. Okay. All righty. Oh, and that was choice. C. Nice. As in derivative. Okay, 20, you got a piecewise function. First of all, they want to know if the limit exists just of the function as x approaches 3.
So put them equal to each other first.
Well, in other words, for the limit to exist, that means as x approaches 3 from the left, whatever, yeah, they have to be the same. So when you plug 3 into the x here, it has to equal the 3 there is there. You get the same thing?
Yeah, the limit exists.
3 plus 2 equals 4 times 3 minus 7. Check. Okay, so it's definitely to be continuous. There's only one extra requirement. To be continuous, the limit's got to exist. It's actually 2 requirements. The function has to exist at 3. What does f of 3 actually equal? Okay, f of 3 actually does equal 5. So we got the limit as x approaches 3. That exists. That was equal to 5. The function at 3 exists. That equals 5 because there's this equals here. And are they the same? Yeah. So where it's heading, where it gets to, they're the same, so it is continuous.
So it can't be
To be differentiable means that the derivatives, the slope's got to be the same when you come in from both sides. So you do a little first derivative equals derivative of the first branch. But you can even look at it. It's a line, so you know what its slope is, but it would be 1. And do the second branch, its slope is 4.
so obviously
No. So with this graph, it's not going to be differentiable. It's not the same. There's nowhere to plug the 3 in. It means this, because what it is with this graph, they're saying that the slope is 1 when you get really close to 3 from the left. And this was the 0.35, I think. So it has like a slope of 1 coming in from the left. And from the right, the slope is just 4. So there's a corner there. Derivative doesn't exist, right? Because it's different slopes coming in. So the answer. So 1 and 2 only. D. Oh. They give you a graph of the second derivative, and they give you its equation. Right? And they say, for what values of x does the graph of f have a point of inflection? Right? When the second derivative changes sign. Right? It's both.
it's just showing
I don't know. So at A and 0, not B. And I just want to, again, because I've been trying to draw your attention to it, when you notice that when x is to the first power, okay, so when that factors to an odd power, there's a sign change. This factors to an odd power, there's a sign change at A. But when it's a factor is to an even power, like x minus b, there's no sign change there. All right, so anyway, so 0 and A was the answer. Enjoyable. I wish every question was that same question, just 43 times.
But these questions are
2.
very straightforward. Like, if you know it, you know it. If not, no.
Right.
They should make every answer. They should make every answer.
Like if I had to take a derivative of the log on the AP test, I'll cry.
Why? It's just,
We've never done a log question in this class.
if you take the derivative of log,
Never done that.
it's u prime over u.
I thought that was ln.
Ln is a log. It's log base e.
Like a log with like a different thing.
Oh, then all you have to do is, like, if you have, this is just to the side, kids. Wait a minute. All right, we were just discussing how do you take the derivative of a log of another base, and this is the general formula. It's just like taking the derivative ln of u, it's u prime over u, but you have an ln of that base down there. All right, let's see what this question says. You're given a graph of the derivative. They tell you, you're given a graph of the derivative, and they tell you that f of 0 equals 5. Oh, and they want to know what f of 1 is.
I never know when to that five, like the new and the old.
You could do the new and old here. I usually tend to just do that one on the calculator, but that's definitely true. You want to do the new old here? I usually say let's do it. All right, you have a point on the function, and you want to know the new y value. Like this is like your old point, and you have a new point. So if you want to find the new y value, you take the old y, yeah?
Maybe you should mention that.
I explained it to our viewers at home. They're fine with it. They're okay. Should I get rid of it? I'm sorry, kids. Is this distracting you? Now you are no longer distracted. It's the old y value, plus the total change, plus the change from the old x to the new x of the derivative. Thing is, you got to come up, either way, you got to come up with a formula for the derivative. You're looking at a graph of the derivative. You got to know what the equation of that is. Can anyone tell me what the equation of this line is? The y-intercept is 6. What's its slope? Well,
The slope is 6. The line is 6x. Right?
Slope, if you look at these 2 points, it's down 6 over 1. Right? So the slope has got to be negative 6 over 1 or negative 6. You could write the coordinates of these points and do change of y's over change of x's. But the slope of that line is negative 6, and the y-intercept is 6. So the equation for this line is negative 6x plus 6.
Could you just find the area on this point?
That is even better, because that's what that's what this equals. The definite integral from 0 to 1 is just the area of that. We could save ourselves time. We wouldn't even have to get the equation. Holy mackerel, that was a good idea. What is the area of that? 3, right? So if I want to know what y is at 1, it's the old y, which was 5, plus the change, which is 3, 8. D as in derivative. Okay. From the other way, there's 2 ways to do this, 2 other ways to do this. You could just take the antiderivative of this to get what y is. You're going to have a plus c. Use this point to figure out what c is, and then get f of 1. Plug 1 in.
Don't you comment?
Or you can do this. Yeah?
Can we put that into the y minus y1 equals to m bracket?
Well, you're trying to write the equation of a tangent line? That's not going to help you.
That's not going to help.
Mm-mm.
Because we know the tangent.
No, you have a graph of you have the derivative. You have dy dx equals negative 6 plus 6. So y is negative 3x squared plus 6x plus c. You got the 0.05. So c is 5. So you have y is equal to negative 3x squared plus 6x plus 5. And then you can get what y is when x is 1 if you plug 1 into here. Negative 3 plus 6 plus 5, which is going to be 8. Okay, so that would be probably like more old-fashioned way of doing it. Actually figuring out what, take the antiderivative, figure out what c is. This is like, I'd say, the second, a different way of doing it. So, you'd have to, if you want to get what f of 1 is, it's f of 0 plus a definite integral from 0 to 1 of the derivative. But realizing that was just the area underneath was very good. Big time saver. Oh, and 23, taking the derivative of a definite integral. I'll help you remember how to do that. That's second FTC.
They just cancel out each other.
The second fundamental theorem of calculus, so that corollary, derivative of upper, plug in upper, minus derivative of lower, plug in lower. Does that sound familiar to you? Obviously, it does not. When you want to take the derivative of,
I was thinking if that derivative cancels the integral.
only if it's 0 to x, then you just replace it, because then it'll just be derivative upper will just be 1. Okay, yeah, I'm sorry, any constant to x. What you do, I'm sorry, you don't have to take the antiderivative first. Like, all you do is to take the derivative of this, it's just derivative of the upper, which is 2x, times what you get when you plug in that upper limit in for t. So x squared cubed, which would be x to the 6. And it's just going to be, it'll be minus 0, derivative 0, 0, and then you plug in 0. But we don't care about that. Okay?
Now we need to get the derivative of that.
No, this is the derivative. That's it. This is how you take the derivative of a definite integral. That's it. Okay? 28 without the calculator. So this is choice A. A. Wait, what are you talking about from the last one?
Yeah.
That's when that stuff you must know cold. Okay, because what we did when we actually, see this one's hard because you can't really do it any other way until except applying the theorem. If you take something that you can integrate, plug in the upper limit, lower limit, subtract, and then take the derivative of it, you'll see because of the chain rule you wind up with the derivative of the upper there, and it'll make more sense to you. If you just, I would change this like to just sine of t. Actually, find the antiderivative, 0 to x squared, and then take the derivative so you can see where this is coming from. But now that's all you got to know. You got to know. This is one of those things you must know cold. Guaranteed question on it. Yes. 24 and your flashcards. Flashcards online, the e-board flashcards. Or if you see, then you, I know, so much. No, just for this class. Just for this class. You got a function. Which of the following is an equation of the tangent line where x equals -1? Equation of the tangent line. This is like, let's just put a bow on this because this is a present. All right? That's what we want. They're asking us to write the equation of a tangent line. We love this question. We know it's going to be there. All right, I'll give you a second to do it. Let's see. All right, write an equation of tangent line. We use a point slope formula. To get y1, you got to plug your x1 into the function. So when you plug -1 into the function, we have -4 plus 5 plus 3. What's that, kids? -4 plus 5 plus 3. 4. To get your slope of your tangent line, you got to plug the x1, the -1, into the derivative. And the derivative okay, so when we plug -1 in there, we get 7. So our equation of our tangent is y minus y1, which was 4, is equal to the derivative, which was 7, times x minus x1, so it'll be x plus 1. And they've solved for y, so we should solve for y to see which one it is. So if we distribute and combine, we would wind up with, we have 7x, we'd have 7, but we're adding the 4. Is that what you kids said? Did you say choice C? Yeah? All right. Okay, 25. Oh, motion problems. We love this. They gave you the position function. They want to know when it's at rest. All right, 25. Here's the position. Want to know when the particle's at rest. So what do I got to do? Got to get velocity and find out when it's 0. So first we got to get the velocity, which is the derivative. This one is kind of a present. You're right. Here's the velocity. We want to know when it equals 0 because that's when it's going to be at rest. Factor out the 6. Two numbers that multiply to positive 12 and add to -7. That's them. Easy. Alrighty. 3 and 4. Choice E. My goodness. 26. What is the slope of the line tangent? Code name. Slope of the line tangent. Derivative. Oh, but look at this. We were expecting you. What is this? Implicit differentiation. You can expect one of these. All right, you kids do it. I'll write the problem up here. Oh, I'm still recording? I didn't mean that. So. Okay, implicit differentiation, you got to get dy dx, but it's not going to be, you have to do a couple extra steps when you have the, it's not just y equals a function of x. That would be explicit. So we're going to take derivative of each term using all our little rules. So we have 6y dy dx. If you're taking the derivative with respect to x and the variable is not x, you need to multiply by its derivative following the chain rule. So you got your 6y dy dx minus 4x equals derivative of 6 is 0. But the next is a product. And I like to include what's out in front in my first term so I don't have to distribute later. So I'm going to let my first be negative 2x and my second be the y. So when we do the product rule, we have first negative 2x, derivative of the second, plus second times derivative of the first. So it would be minus 2y. You get all your dy dx terms on one side, and you can pull it out at the same time and move all the terms without a dy dx on the other side. So over here we would have a 6y, it would be plus 2x when you moved it. On the other side, when you move the 4x, it'd be positive 4x minus 2y. We divide. Minus instead of plus. And then it's just a question of plugging in the coordinates 3, 2. So we want to get the derivative at the point 3, 2. So it's 4 times 3 minus 2 times 2 over 6 times 2 plus 2 times 3. 12 minus 4. So that's 8 over 18. 8 over 18. 4 over 9. Choice B. Now 27 is probably the one that you're going to like the least, but once you know this, guys, in case this question comes up, it is a good thing to know.
I knew how to do this, I forgot.
Here's the thing about inverses. When you take the composition of a function and its inverse, you always get x. Of x, you get x.
That was what I was asking.
And if you found the derivative of both sides, if you applied the chain rule, you would take the derivative of f prime, leave the inside alone of g of x, times the derivative of the inside, g prime of x. That would equal the derivative of the other side, which would be 1. So when you divide, what you find is that if you want to find the derivative of an inverse, what you have to do is take 1 over the derivative of the function at g of x, not x. So it means at the y value. Okay? So it's just the reciprocal of the derivative of the other one, but you're not plugging in the same x into it. And so if I want to find, in this problem, let's see what they told us. They told us that g of 2 equals 1. That's important. They always have to give you a point. Because what they're asking us to find is g prime of 2. If I want g prime of 2, I have to take 1 over f prime, but not of 2, of g of 2. And what is g of 2? No, I'll write g of 2. Yes, well, every time they ask you to find the derivative of an inverse. So you're going to be doing 1 over the derivative, and they had to tell you what g of 2 was, or you couldn't do this, right?
Yeah.
They told you g of 2 was 1. So we got to get the derivative, plug in 1, and then take the reciprocal. So f prime of x, 3x squared plus 1. We're going to plug the 1 into it. So 3 plus 1 equals 4. And so if we want to know what g prime of 2 is, it's going to be 1 over 4. So the derivative of an inverse is 1 over the derivative of the function, but at the y value. Last question. This is a non-calculator. Let g be a twice differentiable function with the first derivative greater than 0. What does that mean? Okay, well, the first derivative is always positive, so what does it mean about the function? It's increasing, okay? And the second derivative is positive, is always positive too, so it's always concave up. So g is some function that's increasing and concave up. Now they gave us some numbers here to work with. G of 4 is 12. I'll write this down. G of 5 is 18. And they want to know what G of 6 could be, one possible value.
Can be A or B. Correct?
What is that?
Cannot be A or B.
Okay, definitely it cannot be A or B because you know this is increasing. So G of 6 should be greater than those. So that's good. You're getting rid of those. Now what if it just increased at the same rate? In other words, G of 4 is 12, G of 5 is 18. If it was just a line, if it wasn't concave at all, okay, we had the point 4, 12, 5, 18. What would it be if it was a 6? It would be 24, right?
So we eliminate 24.
But it's not just increasing like this. It's increasing in concave up. So if you got something that's increasing in concave up, you expect that that next change in y should be greater than the old change in y because the change should be increasing. That's why the second derivative is positive. So you have to find a number that's greater than 24 because of the concavity. That change has to be increasing, and there's only one number there. Didn't we have a question kind of like that? I'm pausing.